Hello and welcome. This is Bryan R. Avila reporting for multiplexers and demultiplexers. So what is a multiplexer? Multiplexer transmits large number of information channels to smaller number of channels, selects binary information from one of the many inputs channels, and transmits to a single output line. It is also called as a data selector. Two and input channels can be controlled by n numbers of select line. Input line is selected according to the bit of combinations of the select line. So here we have a 2 to 1 multiplexer. Here's the truth table of a 2 to 1 multiplexer. So if SO stands for selector, IO is the inputs IO and I1, and O is the output. So as we can see here, if 0 0 0, both all of the pins is 0, we will have an output of 0. So but first let me just create the schematic diagram. So we will need an AND gate for the selector, connecting it to the first AND gate. Then the I0 is also connected to the first AND gate, while the I1 is connected to the second AND gate, and connecting it to the other one. Both of the AND gates will be connected to an OR gate. And the output. This is the output. So now we can see let's simulate it. Okay. Now we can see that if the selector is 0 and both of the inputs is 0, the output is 0, which is proven by the schematic diagram. If the I1 is 1, here we can see that the output is also 0. If IO is only the having an input, it's 1. You can see that if the selector is 0, it will take the input of A. So in this case, the A is I0. So now we can see that if the selector is 0 and both of the I is 1, it may seem that the selector also chooses the I1, but in reality, the selector only chooses the I0. So now if the selector is 1 and both of the inputs is 0, you can see that there's no input here, so the output is 0. Now if the selector is 1, it's the other way around. It will choose the I1. So as we can see here, the output is 1. If the I0 is 1, it will just have an output of 0. And if all of the pins have a input, it will have an output of 1. So this is the truth table for a 2 to 1 multiplexer. It's a schematic diagram using the gates, and here is a schematic diagram for a multiplexer having a multiplexer. So let's try this also, and see that if in this case this is the selector, this is I1 I0, and this is I1. So 0 0 0, we have an output of 0. Now 0, I1 is 1, you can see that the output is 0. If IO is 1, here we can see that the output is 1. If both of the inputs is 1, you can see that the output is also 1. can see here. Let's just try it. 0 0 1. Okay, so I won. So here and all is okay. Yeah. There you have it. The 2 to 1 multiplexer using a real multiplexer, not using a gate. Now we have a 1-bit selector. Sorry. You can see here that the it happened. Okay. Now, same as the 2 to 1 multiplexer, if all of the pins is 0, the output is 0 because there is no input. Now, let's try also this truth table. If I1 is this I1 is 1, we will have a output of 1 on the XNOR gate, because in a 2 to 1 multiplexer, the output is the input is coming from XNOR, and therefore the output is coming also from XNOR. So here we go. If the I1 is 1, the output is also 1. So the same as the here 0 0 1 1. So both of the inputs have an. Now you can see that the input is going through the OR gate. If only the selector is open, then it will it has nothing to select, so the output is 0. If I1 is only open, so we can see here that the selector selects I1, so it has both outputs. If IO is 1, yeah. So we can see that also that if the IO is O has an input, it has also an output on both OR and XNOR gate. All is open. There we can see that the selector does not pick anything because it has both of the pins is open. Now going to a 3-bit selector. Here we can see that in a 3-bit selector it is a mostly combination of a gates and a multiplexer. So let's simulate this also. There we can see it's up and running. Now going to the multiplexer. The multiplexer is designed to switch one common input line to the one of several output line, also known as data distributor. So, multiplexer is a data selector, while the multiplexer is a data distributor. Takes one single input line data and then switches it to any of a number of individual output lines one at a time. Function is to switch one common data line to any of the 4 output data lines. So here is a truth table for common demultiplexer. So as we can see here, this data input, we have S0, S1 and S0, we have the outputs of Y3, Y2, Y1, and Y0. So if both of the inputs is 0, Y0 is all having the output. If S0 is only having an input, Y1 is having an output. If S1 is having an input, Y2 is having an output, and if both of the inputs having an input, Y3 is having an output. So as we can see here, this is a linear relation. So here is a schematic diagram. So this is the S1 and S0. This is the in. So this is the data. So let's just put a probe so we can try it. Uh, so this is y0, y1, y2, and y3. So let's simulate it. This is an input 0, 0. So the output is on 0, 0. The output is on y0. Now if we have an input on y0, y0 is here, right? So there we have it. The output is on y1. Now if the output is on s1, output is on y2. You have it. This is y2. So y0, y1, y2, and this is y3. And if both of is open, the output is on y1. So there you have it, a demultiplexer. Hope you enjoy my video presentation and thank you for listening.